All right, so today we're going to be talking about dilutions. So the concept of dilutions is basically that we are going to be watering down a solution to make it less concentrated. So the real question is, how concentrated is that solution? All right, so again, dilute means watered down. That's what we say in common English. This is useful because many lab chemicals, like acids, are purchased as concentrated solutions. They're more economical, they're cheaper, they're easier to store, they take up less space. So we buy these concentrated or stock solutions for many reasons. These are very, very concentrated. So sometimes we'll get 12 molar hydrochloric acid or 12 molar sulfuric acid. This is insanely concentrated. This is like the stuff that will literally eat through your clothes or your skin. Obviously, we don't want to put that out in the actual lab because it's just way too strong to be used for everyday purposes. So what your chemistry teacher does is they take the very concentrated solution or the very concentrated acids or other mixtures, and basically we water them down. So more dilute or watered down solutions are prepared by taking a certain amount of the stock solution and diluting it with purified water. We want the purified water to make sure it's not contaminated with anything. So here's just a visual of dilute versus concentrated Kool-Aid. So here we can see some very dilute or watered down Kool-Aid, kind of wimpy. And then we see some very, very strong Kool-Aid. Okay, this is like we poured the whole packet into one cup and didn't bother to add the right amount of water. Okay, so we can see the color changes. That's one indicator of how concentrated it is. Or you can actually calculate the concentration. So dilutions, basically we have to consider that the amount in moles of solute before the dilution is the same after. So we're not changing how much solute is in there. So if we go back to the previous slide, it could be the same amount of Kool-Aid mixture in each cup, but maybe we put a different amount of water in there. Something along those lines. Okay, so although the number of moles does not change, the volume does change quite a bit. So thinking back on the very concentrated acids, I can take just a few milliliters of some of that very concentrated acid, and I can make enough of the dilute solution to give to the whole class for the experiment. All right, so the concentration of the solution is going to change because we know that molarity is moles of solute over volume of solution. So if we're changing the volume of the solution, then our molarity is definitely going to change. All right, so the goal of dilutions is to take a very concentrated stock solution that you start out with and basically water it down to something that's more practical to use. All right, so let's look at how to do dilution calculations. So when a solution is diluted, the concentration of the new solution can be found using this equation. M1 times V1 equals M2 times V2. This is the starting concentration times the starting volume is equal to the ending concentration times the ending volume. Okay, so this is what we have to use whenever we are looking at dilutions. All right, so let's take a look at how to solve some of these problems. Notice that if you look at the equation, this looks very similar to what we dealt with when we were looking at Boyle's law. So you might want to refresh yourself on how to do that. Basically, it's an inverse relationship where one value goes up, the other value is going to go down. All right, so let's look. What is the concentration of a solution prepared by diluting 25 milliliters of 6 molar hydrochloric acid to a total volume of 50 milliliters? We know our starting volume is 25 milliliters. We know that our starting concentration is 6 molar. We know that our ending volume is 50 milliliters. This is our total volume. That's our ending volume. I want to find the ending concentration, M2. All right, so we're going to use this equation, M1 times V1 equals M2 times V2. Now, because of the rules of multiplication, you can flip V2 and M2 as long as your 1s and 2s are on their respective sides. All right, so we're going to solve for M2. So we're going to plug in these values that we just pulled out of the problem into this equation. Note, the volume values don't have to be in liters. However, they need to be in the same units. So if this is milliliters, this also needs to be in milliliters. If this is in liters, this also needs to be in liters. You cannot mix your units right here or you will mess up your answers. All right, so let's look at how we would do this. So I would do 25 times 6 is equal to 50 times M2. So I'd do 25 times 6, rearrange, divide by 50 to get rid of that V2, and that would be my answer. All right, so whenever we're making a dilution in the lab, we have to know our volumes that we're shooting for. All right, so you have to know the amount that you need to dilute. So you need to be able to pull out a certain amount of the stock solution. And you need to know what your target final volume is going to be so that you can get the proper volumetric flask. This is a volumetric flask right here. You'll see that if you look very carefully, there's a little line right above the base of it. Okay, a little bit stronger on here. That line tells you when you have the proper amount. Okay, so it's a measuring line. Okay, they come in different size flasks. So if you're looking for 50 or 25 milliliters or 100 milliliters, there's probably going to be one of those in the lab. So you usually take a pipette like this one to deliver a certain volume of your stock or concentrated solution to a clean flask. Then you're going to add your solvent, which is usually water, to the line on the neck of the new flask, which is that right there. Okay, so you add your solute first, and then you fill to the line with water. And then finally, as with any solution, you need to mix well to make sure that everything gets mixed in there properly. You would not want to pour in Kool-Aid powder into a gallon jug of water and just leave it there to sit. You want to stir it up, or you want to swirl it. Something to get it to dissolve better. All right, so let's look at some more examples of dilution problems. So, how many milliliters of 5 molar potassium dichromate solution must be diluted to prepare 250 milliliters of 0.10 molar solution? So looking at this, I know my starting concentration, I know my ending volume, and I know my ending concentration. That means that I'm looking for my starting volume. All right, so my starting volume, I don't know. My starting concentration, it told me was 5 molar. My ending volume was 250 milliliters. And my ending concentration is 0.10 molar. All right, so I'm going to plug this into my equation. M1 times V1, 5 times V1 is equal to M2, 0.10, times V2, 250 milliliters. Rearrange it to solve for V1. So I'm going to do 0.10 times 250, divide by 5, and that gives me 5 milliliters of stock solution that I need to use to prepare this combination. Let's look at another one. If 10 milliliters of a 10 molar stock solution of sodium hydroxide is diluted to 250 milliliters, what is the concentration of this solution? All right, so in this one, I'm looking for my second concentration, my ending one. I am told that my starting volume is 10 milliliters. My starting concentration is 10 molar. And my ending volume is 250 milliliters. Again, I'm going to plug in 10 molar times 10 milliliters. So starting concentration times starting volume is equal to ending concentration times ending volume. We want to rearrange to solve for M2. So M2 is going to be 10 times 10, that's 100, divided by 250. We want to get rid of that 250, which is going to be 0.4 molar of diluted solution. Make sure that when you are putting your units that you are capitalizing them properly. If it's molar for molarity, it's a capital M. If it's milliliters for volume, that's a lowercase m and a capital L. If it's liters for volume, that's just a capital L. And that's basically all the ones that you have to worry about for dilutions. Okay, it is very important that you capitalize them, because if you don't, then it could mean something very different and your answer could be interpreted as incorrect. So that's about it as far as dilutions. It's basically just trying to water something down so that we can have a more safe and practical solution to use in the lab.